So welcome everybody to my presentation about modularization as the foundation of microservices and monoliths. Feel free to ask any questions that you might have in the chat or later on via audio. So a few words about myself. So my name is Eberhard Wolff. I'm with InnoQ. We are mostly doing software development projects. I'm sort of an exception, so I mostly do consulting. I've actually written a few books about microservices, continuous delivery, and so on. And I'm glad to be here. Thanks a lot for the invitation, and I'm looking forward to do the presentation. So modularization is fundamentally about the question, how can a team of humans develop a system that is too complex for a single human to understand? This is the fundamental challenge that we have in software development, because most of the stuff that we develop is so complex that a single person can't possibly do that. And that is what we need to take care of. And that is where modularization comes in. So modularization is fundamentally a technique to limit the knowledge that you have to build, to do anything sensible in a software development project. So you can either think about one single module that you might want to modify, so you need to understand that. And then there are obviously other modules. So if you want to modify this one module, well, the only thing that you need to understand ideally is that one module. And you can also understand the collaboration between the other modules to have sort of an overview. And those are fundamentally the two levels that you take care of. One goal is to have loose coupling. Modules obviously do have dependencies. Sometimes I hear about how modules should be independent from one another. That doesn't make any sense. They have to have dependencies because they are just part of a whole, and the whole is actually what you're interested in. However, there should be loose coupling, and loose coupling means that a change to a module should not influence other modules ideally. So here is a change, and that change just is local to that one module. And here is another change. And this time around, there are two smaller changes in these two modules, but no further changes. So that's loose coupling. It's about changing one module and either limiting the change to just one module or to have some influence to other modules. So why would you do that? Because then software is easier to understand. You just take care of one module and you just need to understand one module, and therefore it's easier to change. So it's a technique that is fundamentally about humans. If we had unlimited brain power, there would be no need for modularization. And it also depends on typical changes. So if you want to be able to do changes, then you need to understand which changes are the typical changes. And those are the ones that should be covered by loose coupling. There are some examples where people are arguing that architecture went wrong. That is something that I also discussed yesterday in my presentation. And one more or less famous example that you could give is the Netflix architecture. There is a video that talks about that in more detail. And what people seem to think then is that, well, nobody can possibly understand this. So what you're seeing here is the microservices that Netflix has and all the dependencies. And as you can see, that's a rather complex graph. And I would actually agree that nobody can possibly understand that. However, as I said, that's fundamentally the challenge that we're facing all the time. The software that we are building is too complex for one human to understand. So obviously, for any piece of software, you can present a graph that is so complex that no human can understand it, because that's the whole challenge that we have in software development. So instead of arguing how this is a bad example of an architecture, we should rather ask the question, how can Netflix possibly work? Because it actually does work, and they do provide new features. And I think the only explanation that I can think of is, if there is a person developing software at Netflix, that person probably only understands a very small part of the whole system. And that is actually what I was talking about. It's about limiting knowledge. It's about information hiding. And that is the only way how we can possibly build such software. So maybe the successful modularization that Netflix applied is the explanation why Netflix is still around and why they are still able to change software. That's a hypothesis. I'm not familiar with Netflix in a lot of detail, but we have to admit that Netflix can actually change their systems, and so can many other organizations. So maybe that architecture is a victory of modularization in a way, and that is just something that I want you to think about. So far, I've spoken about what a module, what characteristics a module should ideally have, but I haven't really given any sort of real definition of a module. And with the focus on modules nowadays, I think that originates from microservices. With the focus on modules nowadays, I think it's interesting to look back on the origins of the term module and the idea of modularization. And that idea is actually older than me. So there is this famous paper by Parnas from 1971 called On the Criteria to be Used in Decomposing Systems into Modules. And you can still download the paper as a PDF. And my former colleague, Adrian Keuler, has this very nice website where he talks about a paper every day. And there is one discussion about that very paper on his blog that also talks about how this is relevant to nowadays with microservices. And there is actually a comment that Parnas himself made on that very website. So if you don't want to read the original paper, you probably should, but if you don't want to, then you should go to Adrian's website and take a look at what he said about that paper there. And what Parnas says in his paper is that modules should not implement process steps, and instead they should hide design decisions. So one example that he gave is that there should be a module that actually talks about how data is stored. There are two competing modularizations that he suggests, and one of them spreads the knowledge about how the data is stored in a lot of different modules, and the other one hides that away in one specific module. And that the result obviously is that the module is quite stable against technical changes. So he talks about different types of changes, in particular about how the data is stored. And it's not really that surprising that at the end of the day, the system is stable against these kinds of changes. If you hide away the decision how to store the data and you change that decision, then obviously your system will be stable against these kinds of changes. I wonder whether those are still the most frequent changes. If you read through the paper, and if you compare that to modern days, projects, usually when someone calls me in to do some architecture consulting, it's not about how can we make our system stable against choosing yet another database and having a completely different type of technology for doing the UI or whatever, but it's primarily about how can we make sure that the changes that we are doing to the business logic, that those have limited impact. So I would argue, and I have to admit that I feel somewhat guilty about saying how Parnas might not, how Parnas discussion might not be valid anymore, because Parnas is such a huge and important person in computer science. However, I would argue that nowadays what we do is changes to the business logic. And hiding design decisions is still, of course, important. I'm not saying that we should spread the knowledge about how data is stored in a lot of different modules, but hiding the business logic is probably more important. And I'm not sure whether we are doing that. So if I look at most of the discussions that I have when it's about encapsulation, I have my sort of feeling is that those discussions are primarily about hiding technical decisions and not so much about business logic. But your mileage might vary, so you have to think about that yourself. So I would argue that it's obviously still not a good idea to use other modules' internal data structures, but separating process steps might be a good idea nowadays. And I would recommend that you read the data and the paper and make up your own mind concerning that. So that's one paper. And as I said, that doesn't really tell us too much about how we should be doing modules nowadays, I would argue, because it's such a trivial example by today's standards. It's just that nowadays, about 50 years later, we are building different systems on a different scale. So the original example is about something it's fundamentally about shifting and sorting text. And that is something where you would nowadays just use some library and wouldn't program it yourself. There is another paper called Information Distribution Aspects of Design Methodology. And again, that's by Parnas. And again, there is a link to the paper, and there is a link to Adrian's discussion on his blog about this paper. And there is a very fundamental hypothesis in this paper. And this paper says modules can be changed freely if they still meet the expectations that other modules have. So as long as whatever those other modules expect from the module that should be changed, if that is still kept, then you can do whatever you like. And there is another hypothesis that says other modules, developers, they are smart people, so they will use all the information that they can ever get about a module. And the conclusion from that is you should hide as much information about a module as possible. Because if you do that, then less information will leak to other modules, and therefore your modules are easier to change, because there is just so much information that you expose, and a lot of the information is hidden, so the hidden information can be changed. So you can change your implementation as long as the information that has leaked out is still valid. And this is a rather abstract, fundamental concept that I think is really, really fundamental even nowadays. And basically what this says is, if you have a module, then there is, well, internals that are changeable, and then there is public information. And that's fundamentally what a module is like. And if you look at Parnas' original discussion, he said that there are design decisions inside the module, and the information that is leaked out is, for example, the documentation, which is quite interesting, because nowadays you wouldn't think about documentation or the lack of documentation or just documenting specific parts as a way to do information hiding. So nowadays, what you would do is you would say there are design decisions and business logic that you want to hide. And the primary way how you hide that is by having an interface that exposes some methods, some things that you can call, and then the implementation is internal to that. There is other public information that would leak out too. So one example would be the runtime behavior. If your system, if your module can do some calculation in some amount of time, then probably other modules will rely on that performance characteristic. And if you change that, if your system becomes slower, then you will have a problem. So that is an example of some information that leaks out, that becomes public, and that other modules might rely on. Modules do come in different sizes. So I would argue that there are methods, it's very fine-grained modules, and they expose a method signature, and they have some implementation. Then there are classes, and classes expose a public interface composed out of all the public methods that those classes have. And then there are, for example, Java packages to structure classes into larger clusters. And again, there is a way to do information hiding. So you can have public classes that can be seen outside that package, and you can have package protected classes that can only be seen inside that package. So there is a way to limit the information. Then there are microservices. And again, there is an interface for a microservice, or there are Java jar files, for example, as a more coarse-grained type of modules. And then there are bounded contexts, and I will talk about that later on. I would argue that there are also teams as a way to do, as sort of a module, because a team also exposes usually some kind of interface, and you will have interface negotiations about those interfaces. And then there are systems, and systems expose, again, interfaces. And in your organization, multiple systems will talk with one another. This hierarchy is very important because the problem that you have is if you have hundreds of modules, that won't fit in your head, or at least it won't fit in my head. I'm not sure about your head, but usually that is a problem. So on each of those levels that I've presented here, you should have a certain number of modules that you can still keep in your head and understand, because that's the whole idea about modules. So as soon as you have a lot of methods, you should build another class. As soon as you have a lot of classes, you should build another package, and so on and so on. So you should build larger modules that are composed of smaller ones. And of course, information hiding still applies. So if you have a class, you should limit the number of public methods. If you have a package, you should limit the number of public classes, and so on and so on. And the idea is to leak as little information as possible. So, and that means that, well, nobody can understand a class with 1,000 methods. And that means methods remain changeable because you will split them apart into new classes, and therefore you will make sure that there is never a class where you have to understand 1,000 methods, because you can't possibly do that. And I guess that is also what we see at Netflix. So Netflix on the level of microservices is not understandable. So, but it's still somewhat changeable. So I would suppose that they have some higher up level of modularization where someone can still understand the modularization. And that is about, I would argue, coarse-grained information hiding on the level of teams, bounded contexts, and probably whole systems. And one thing that I want you to think about is if you have too many meetings and if you have too many discussions, maybe that's because there are too many dependencies between teams or bounded contexts or systems, and a way to limit those meetings and to limit those dependencies is to practice information hiding. So to make sure that only little information about your system leaks to the outside. And again, that's a nice way to give a goal to people to practice information hiding. But what does that really mean? What are great modules? Well, again, that's a discussion on several different levels. So if you talk about a method, there is an implementation, and there is the signature and the execution time and the memory consumption. And if you limit the knowledge, then you do have a way to modify your methods more easily. If you have a class, then it's the instance variables that are hidden inside the class, the implementation details. You should definitely not expose your instance variables. And the signature would be the public methods. And there is a very old, it's about 20 years old, a very old way to think about classes. And that's the CRC cards. So the idea is to have a card, and on the card it says, this is the class, so it's order service, and the responsible is, well, to accept orders. And here is a collaboration, so it collaborates with several different classes, and that's why it's called CRC classes. CRC is an acronym, and it's class responsibility collaboration, CRC. And you can now try to understand how your system could work by, well, playing a game of cards. and each person has a set of cards, and he or she would say, okay, I'm the order service and I have to accept an order. So I store the order in the order repository, and the order repository, probably played by another person, would need to have a responsibility to store that order, and so on, and so on, and so on. And bounded contexts are, as I said, a more coarse-grained way to structure your system. We will talk about that later on. And again, what you have here is your code or your systems that is hidden, and there is an interface. And what I find interesting is that there is a way to think about bounded context too, and those are bounded context canvas. And here is the name. So in my case, it's the payment bounded context, and it should be a core context, so it's very important. Here is the description. Well, it's processing payments. It has some inbound communication with the order processing. It has a ubiquitous language. Those are the terms that are used inside that bounded context, and it has outbound communication. I would argue that this is the same idea as CRC cards on a different level, because this is essentially the collaboration, inbound and outbound communication. This is the sort of responsibility, and therefore it means that we basically have the same thing, just on a coarse-grained level. And then we have teams, and again, there is the code and the interface that they will provide. And a great module would be a module that isn't too fat. So it should be small. It should have a small number of parameters. If you look at a method, it should have a small number of public methods, a small interface, and so on and so on. And it should have not too many tangles. So if you look at a method, there should be a low cyclomatic complexity. That's the number of paths, execution paths that you can take through a method. And you should have not too many dependencies. So with metrics, and I think so what you could do now is you could say, okay, I'm such an intelligent person, so I would take the problem at hand and I would just come up with some architecture and some split into methods, classes, and so on and so on. And I have to admit that I can't do that because it's much too complex. The whole idea is to, well, not do that, but to limit yourself and to do it, well, with limited knowledge. So probably you need to do it stepwise. So I would believe that the system that you're building won't be perfect from the start. And if you do changes, if you add more logic to a method and more logic to a method and more logic to a class, then it will become worse. It will become fat at one point. So you can find some problems by looking at metrics, and then you could do refactoring. And that is an established development technique. So as we all know, we should, when we do some implementation, we should do some refactoring to make sure that we can do the change easily, and then we should do the change. So in order for you to come up with a great architecture, you need to be able to change that. You need to do refactoring, and you need to understand what the system does. But if you have some metric that says, okay, this method is now, the cyclomatic complexity is quite high, then it points you at some problems that you should think about and that you should fix. But you still need to figure out how to do that. And you could ignore those metrics because you could say, well, this is something that really doesn't matter and I'm not going to change it, or I have no good idea how to fix the metric. So you have to think about how you do it, where you do it, but the metrics at least guide your way. As I said before, microservices are just a different type of modules, and there are other ways to structure your system on that coarse-grained level. So for example, you could have jar files. So there are other type of modules that are alternatives to microservices. And now the question is, why would you do microservices and how are they different? And the first thing that I want to say here is there are alternatives, but you still need to have some kind of coarse-grained modularization. And I would argue that microservices are high-risk, high-gain modules. That's something that I sort of stole from investments, financial investments, because in financial investments, if you want to have a high gain, then you have to take higher risks. So if someone says, okay, this is something where you get 5% per year, then that's a higher risk than when you get 1% per year. And so you might possibly get 5%, but you might also end up losing all your money. While with the 1% gain that you can get over a year, you probably it's less likely that you will lose your money. So there is higher risk but a higher gain. And as I said, that's something that you get from that's an idea that I stole from investments. So why do I say that? Well, as I said before, if you have loosely coupled modules, then you only need to understand one single module to make a change. However, if you have badly designed modules, then you need to understand multiple modules because they are not loosely coupled, and a change in this module will also influence these modules. So you need to understand 3 modules in that example. And that's something that is bad for developers. But if you have those modules and they are implemented as microservices, it's actually worse because you need to understand those modules, but that's the same whether you use microservices or not. But in case of microservices, you also need to deploy them together. So you split your system into several units that are independently deployable, but now a change causes several of those modules to change, and you need to deploy all of them. So that's more effort. And if your system, if something crashes, well, then those other modules might crash too, because there are those dependencies, and those microservices will probably talk a lot with one another. And if one of those microservices becomes unavailable, the others might be influenced. And because the communications over the network, also the performance might be bad because they are so chatty in the network communication. If we have well-designed modules and they are loosely coupled, then you just need to understand one of those modules. And if you have microservices, then it's not just about the changes, but you can also deploy them individually, independently. If one of them crashes, then it's limited to that one microservice because that one Docker container only crashes, and the performance is also fine. So if you have a great modularization, there is much to be gained if you're using microservices. That's sort of the idea behind that. And the question now is, how do you actually do that? And how do you end up with well-designed microservices? And well, they are just a different type of module, so the rules still apply. And we discussed how, for example, the architecture won't be perfect from the start. But in this case, changes that you do on the level of microservices are different because me as a developer, I'm sitting in front of my computer, I can do refactorings on class level. That's not too hard, and it's often also supported by the IDE. If I want to change some responsibility and shift it from one microservice to another one, then that's more complex. There might be more stakeholders because the other people in my team need to agree on that. Maybe my PO needs to agree on that, and we have to put it on the agenda. We have to put it on the backlog. And I think some questions that you could ask is, when did you last do an improvement on that level, on that coarse-grained modularization level? You will have that kind of level in your project. When did you do that? and what is the process. And chances are that your process will not just be something where architects need to agree on or developers need to agree on whether you want to do the change, but also architects, POs, and several other stakeholders. And I'm doing a review right now, and I think in that specific case, I'm not sure whether there's such a process in place, and it is something that architects by themselves cannot decide because there are so many other factors that you need to think about. Concerning what Parnas said, well, probably modules shouldn't be process steps. That's what he said. They should hide design decisions. But as I said before, Parnas' example is trivial by today's standard. And if you look at domain-driven design and event storming, in particular event storming, you will probably rather end up with some modules that are process step-like, or at least that's a major influence on your system. So maybe that is something that will lead to better modules, and it is something that techniques like event storming will actually force you or lead you to do. There is another discussion. So we are still discussing how microservices, what great microservices would look like. And I want to talk about classes first. So if you think about classes, I think it's obvious, and I've actually shown that slide already, it's actually obvious that instance variables must not be exposed. They are part of the implementation. You are doing information hiding, so they should be local. They should not be visible from the outside. Only the public methods should be visible to the outside. And I guess nobody will argue about that. And the funny thing is, if you look at CRC cards, they actually don't really talk about data. So the order service here, it doesn't say that the order service is responsible for some kind of data. It doesn't say anything about the attributes. So on this level, if you want to think about the design, you don't actually talk about the data. And I would argue that for microservices, we should apply the same principle. So the database containing the data that's analogous to the instance variables in a class should be hidden, and you should only access that from the outside. And bounded contexts are a great way to come up with some architecture that you can then implement as microservices. And if you look at the bounded context canvas, it doesn't really talk about data either. So there are bits and pieces. So for example, in here it says that there is the ubiquitous language, but it doesn't say that you have to think about what data should be the responsibility of that bounded context. Of course, you will need to figure that out at one point, sooner or later, but it's not something that you do from the very beginning. So I would argue it's a bad idea to have the database and share it across multiple modules. That's not a good idea. And I would also argue that if you have an event that exposes lots of data, you're basically doing the same thing because you're exposing data, and data should be hidden. It should be about some interfaces. It should be about some functionality that is there. And I actually did a video where I argued that if you use, in particular, Kafka, you might end up in a situation where you are actually exposing data and you end up with a very monolithic data model that is implemented in in Kafka. And it's, I think, 4 or 5 minutes. So, and the link is over here. And as you can see, I'm not very pleased about what happens there. It's not a problem of Kafka, it's rather how you build those architectures. And I think that, as I said before, bounded contexts are a great way to think about what microservices or those coarse-grained modules should look like. And it's actually a great name. So bounded context says there are bounds, and in these bounds there is a model, which is basically just just code or code, and a ubiquitous language. So there are some specific bounds in which there is a language that people talk about, and there is a model, so there is code that sort of implements that language. That's very abstract, and I'm not sure whether anyone can really think about what a concrete bounded context would look like. So let me give you an example. So I would start off by talking about, well, responsibilities. So let's imagine that there is invoicing. So I want to write an invoice. And that basically means that somehow there is an order, and then an invoice, some PDF is generated from that order. And there is VAT, the calculation of the VAT, the value added tax, Mehrwertsteuer. And that might make sense. That's part of the same ubiquitous language. So inside if you look at some invoice, it says this is the VAT, and that's part of the invoice. So it makes sense to put that together because it's part of the same ubiquitous language. Now, some people might say, well, that's actually not the case. Maybe you're right. That's a discussion about functionality, business logic, and how the business is organized. And I'm not saying that it's always the best way to come up with invoicing and VAT as part of one bounded context, but and it's great if you have that kind of discussion, because it's a discussion about the business logic and how to organize business logic. So that's great. But for my example, I would say that I'm going to say that it makes sense to put them together. So we have the invoicing process, and that is a bounded context, and there is a ubiquitous language here. Parts of that ubiquitous language would be the invoice, VAT, and so on. And then we have tracking to track the delivery. We have the delivery where it is decided how you package the packages and how you put stuff together, how you make sure that it arrives at the customer. And that's a shipping bounded context. And then we have the shopping cart and accepting orders, and that's the order process. And this is basically something that you could do with a bounded context canvas. You could say these are different ubiquitous languages. These are responsibilities, something that you can describe. And now you will at one point need to define data. And if I ask you to write some code that produces invoices, I would be surprised if you wouldn't talk about a customer, because the customer is whoever gets the invoice, and it has a billing address, for example. If I ask you to build a system and for the product, if I ask you to build that system to do invoices, to generate invoices, you will probably also have products, because that is what is given on the invoice. And I would be pretty surprised if you wouldn't need the price of a product to write the invoice. Now for shipping, well, you ship stuff to some customer, so you need a shipping address, and you're shipping products, so you need some information about the products. So if you want to ship a washing machine, that's different from shipping such a clicker, because that washing machine needs to be handled quite differently. So again, there is the customer here just with different data, and the product is here with different data. And in the order process, you will probably try to think about what you can provide to the customer, which other stuff he or she might want to buy. So some preferences would be interesting. For the products, you probably need to have marketing information. So what we are looking at here is the same idea that we have been talking about all the time, which is there is information hiding. The data model is internal. That hides most of the design decisions, also the business logic. It also hides how the data is stored. And that means that bounded context, this structuring of business logic, is a great way to build modules. And this is not by design decisions, but by functionality. And it's probably a better way to structure your system compared to what Parnas said, in particular, if you have lots of business logic. So microservices need these kinds of great modules like bounded context, for example. And in conclusion, as I said, modules are a key to build large software systems. And the reason why, or the principles that we have to apply are information hiding. And if we do information hiding, we will end up with loose coupling. And as I said, modules come in a lot of different sizes. So methods are modules, classes are modules, packages are modules, and so on and so on. And microservices are just a type of coarse-grained modules. And you can easily come up with others, like, for example, JavaPRO, as I said. And those bounded contexts are a great way to structure your system, no matter whether you use microservices or not. Some kind of coarse-grained modularization is probably needed, so you have to probably use that. And on Fridays, I do a show called Software Architecture on Stream, and I'm afraid it's in German. And I did a few episodes about modularization. So you can, if you understand German, then you can go to the website and look at those. And there are several hours worth of discussions in depth about loose coupling, modularization in general, how you can come up with a good modularization, these kinds of things. If you enjoyed the presentation, feel free to send an email to this email address. You will get a link to the slides and several publications, free publications, mostly about microservices. That is powered by Amazon Lambda and, well, microservices. So your email address will be stored for 14 days. That's the minimum time span that I could configure. And if you made some typo in the email address, then I would handle it manually. And I will provide the link to the Dropbox in the chat. So no need for you to send an email. You can just click on that link. But for people looking at the recording, the email address might be valuable. So thanks a lot for listening. I'm open to for any questions that you might have. So feel free to ask them in the chat, for example. During my presentation, there was a question by Mirko Wagner, and he said that just presented module layering seems to describe a one-to-n relationship from lower level layers to layers above. So a class consists of several methods. Does this also apply to microservices and bounded contexts? I thought bounded contexts are a perfect thing for being developed with one microservice. And that's a good question. And as I said, that's sort of true, but then there are, how shall I put it, edge cases. And one of those edge cases could be, so we talked about order processing, for example, and there is a business model for order processing or a bounded context for order processing. And then you might decide that the very last step of the order process where you do, I don't know, the checkout, that is something that is really hard. And you want to separate that because there is so much computing resources needed for that step. So you separate it in a separate microservice to be able to scale it independently. So there is one microservice that does everything but the checkout, and then there is one microservice that does only the checkout. And the reason is that you want to scale the checkout independently from the rest. And I think that's a valid design decision. And they might even share a common model. And that is the reason why I said that there is a one-to-n relationship between bounded context and microservices. So that's a very good question. Okay, but that seems to be a more technical reason. Yeah, good point. And I was arguing about how business logic should be the primary reason for doing, for splitting your system into modules. However, the whole point for using microservices is also a technical one, right? Because in the presentation, I said that you have technical advantages such as independent deployment. I think I also spoke about independent scalability. So the reason for choosing microservices to implement modules are probably technical. I'm hearing someone who might want to speak up and ask a question. Not sure. No, that was just some noise. So any more questions? Feel free to unmute yourself. How would you handle DTOs, especially if you have multiple services processing a common DTO? You may need to adjust all the services if the DTO changes. Do you recommend to centralize them? Well, that's what I was trying to say in this slide. So if you have a data structure, so let me go back another slide, that is on the communication level, so for events or DTOs, that is also something that will lead to a dependency and probably therefore to well, not so loose coupling. The question sort of proposes or asks a question about a common DTO. So that means that for some reason, that's sort of what the question implies, that for some reason it's a given that there is a common DTO, that there is something that they share. Now, you could try to tackle that problem on the business logic level and ask whether that DTO is there because you did something wrong on how you organize your business logic. If you come to the conclusion that it makes sense to share that DTO, that's a decision that you could make. And what I'm trying to say in this slide is you should be careful because that might lead to strong coupling, not loose coupling. But maybe you're lucky and that's not the case. So for example, if the event never changes, then it doesn't matter that there are so many dependencies. So what I'm trying to say is you should be careful, but in software architecture, there are a lot of cases where something that doesn't make a lot of sense in one area makes sense, or in one specific case makes sense in other cases. So if you have a common DTO, sort of what you're implying is that you should probably share it because otherwise you would copy it over, and that doesn't make any sense either, right? So that's it. Would you rather share data objects, or would you prefer that every module has its own data representation, then you need to convert each time when calling the public API of another module? Well, that's sort of what I said in let me dig out the slide. That's sort of what I was trying to say here. Chances are that even though you have a customer in each of these modules, it's really not the same. And then obviously you have to have another data representation. And the question sort of says that this is something that I can actively I can actively think about the data representation. That's not what I'm suggesting here, right? What I'm saying is, as soon as I start writing about writing a module that does invoice processing, I need to write a class for customer, and I need to write a class for product. And because at least me, I can't write an invoice without some information about the product and some information about the customer. So I will have to have those classes, and it seems logical that I have this data in there. So basically the question whether I would have my own data representation, it's not something that I actively decide about. It's just something that is sort of the logical conclusion from this approach, where I start by thinking about the responsibility of the modules. And that is the main point. I think that modules should be organized by responsibilities. This is what CRC cards say. This is what About the Context Canvas says, in my opinion. And then you will end up with that data. This is also one of the moments that's about the DTOs. One of those moments where language change how you think. In Clojure, you can use data without creating DTOs. In functional programming, things are often different, and as you can probably tell, I'm rather from the object-oriented skills, so that's how I think about it. Okay, so no more questions, I guess. So thanks a lot for listening, and feel free to get in touch if there are any more questions. And have a great conference. And thanks a lot to the organizers for having me and making all of this possible. So thanks a lot, and I hope you enjoy the conference, the rest of the conference. Thanks.